Standard 2 of quarter 2. This whole quarter has a lot to do with triangles, if not every single standard, if I remember correctly, is about triangles. The one we just did last week was how do you figure out if they're congruent? Are the triangles exactly the same? Now we get a little bit of a potpourri in this standard. There's a few different topics on triangles. The first one is the center of a triangle. Now if you Google that or if you search for that on the internet, you're going to get up to 4 different theories or preferences on how to find the center of a triangle. We're only going to deal with one of those. So let me draw a triangle for you. What is the center of that triangle? There's different ways to argue what the center is. There's an orthocenter. There's different names for them. We're going to deal with the one that's called centroid. So the center of this triangle, we're going to call that the centroid. And that's a vocabulary term that you're going to have to know. And it basically just means the center of a triangle, but found in a specific manner. All right, so we are going to locate the centroid by performing a task on this triangle. We're going to draw 3 lines on this triangle, and they are going to all intersect in the same spot, like that. And that's going to be our centroid. Now, I just did that all willy-nilly and real fast, and you can't really do it that way. It has to be a specific way you draw these 3 triangles. So let me quit building up the drama and just explain to you how to do it. How you do it is you take a side of the triangle and you split it in half. So let me just start with the left side over here. I'll call this side AB. So I'm going to start with side AB, and I'm going to find the midpoint of AB. Mid meaning middle, point meaning a dot, a point on the line. Midpoint of AB. I don't have a ruler, I'm not going to measure it, I'm just going to eyeball it and say it's right there. That looks like that's pretty much splitting AB in half. I'm going to call that the midpoint. How I'm going to represent that is I'm going to put a little tick mark here and a little tick mark there. I'll call this point D. And now AD is congruent to BD because I just split AB in half and created 2 equal segments, because if you split something in half, you've got 2 equal parts. If you split $1 in half, you've got 2 equal piles of 50 cents. If you split a segment in half, you've got 2 equally lengthed segments. Now to find the centroid, you take that midpoint and you connect it to the vertex on the other side of the triangle, which would be C in this point. We used A and B, you got to connect it to C. So I'm going to connect that midpoint to C, and then I'm going to follow that pattern for the other 2 sides. So I'm going to split BC in half, connect that midpoint to A, and then I'm going to split AC in half. Actually, I want to make it look nice. I'm going to say that's right there. Split AC in half, connect it to B, and that will always work. It doesn't matter how you draw your triangle. You could have a triangle that looks like this, and if you split your 3 sides in half and connect those 3 points to the opposite vertex, they are always going to intersect at the same point. Put it right there. You're never gonna, if you get some picture that looks like this and they don't all intersect at the same point, then you messed up one of your midpoints. You're not drawing this line to the midpoint of the side across from it. And where I messed up this picture is probably this line right here. No way is this segment the same as that segment. So I messed up that picture, and therefore I don't intersect all at the same point, because it always works. So that's a centroid, center of a triangle when you connect from the vertex to the opposite midpoint. So there's your definition. Now there's a ratio for this, and this is where it gets a little bit confusing, is that people think that since it's the middle, since it's the center, that if we take the length of, I'm going to call this I for intersection. I should probably call it C for centroid, but I already used C over here. So I'm going to label our centroid point I. So if I take the length of AI and the length of, well, let's do C because I already named that other point. The length of CI and the length of DI. So that's this little segment right here and this one right there. You would think that since I is the middle of the triangle, it's the centroid, that I would be in the middle of CD. But the eye test tells you that doesn't look right. This segment looks a lot longer than that one. And you can't really go by the eye test, but it usually doesn't lie. And this is not lying to you. That point is not in the middle of CD. CI is not congruent to DI. So that's where it's not intuitive. You would think, like I said, since I is in the middle, it would split CD in half, but it does not. What it does do is it splits it at 2/3, not 1/2. It's not 1/2. It's not splitting CD in half. It's splitting it in thirds. 1/3, 1/3 and 2/3. So what do I mean by that ratio? Let me give you a length to work with here. Let's say CD is equal to 12 inches. Let me give you a unit for all of you out there that are yelling at me right now. CD, we'll say, is 12 inches. If I ask you how long is CI, it is not 6 inches because I is never in the middle of this segment. So these are not 6 and 6. What it is 2/3 and 1/3. 2/3 of 12 is 8, and 1/3 of 12 is 4. So CI and DI, one of them is 8 and one of them is 4. And it's always, always, always the longer one is coming from the vertex. The longer segment is always connecting to the vertex. The shorter segment is always connecting to the midpoint. So DI would be 4, CI would be 8. CI is 8, DI is 4. They add up to 12 because the whole thing's 12. 8 plus 4 is 12. Just remember, it's not 6 and 6. It's always split them into thirds and take 2 of those parts. That's the long section. One of them is the short section. If you divide your length by 3, you'll get 4. And you can take 2 4s, make 8. 1 4 is 4. That's how you figure out the lengths. Let me give you one more example on this same picture. Let's call this point E down here. And I'll say that AE is equal to 9. So if the length of AE is 9, divide 9 by 3, you're splitting it in 3 parts, and you get 3. So we've got 3 sections of 3 basically here. This would be 3, this would be 3, and this would be 3. This centroid is always 2/3 of the way down. So AI would equal 6, and EI would equal 3. The centroid is always 2/3 of the way from the vertex to the midpoint. The vertex one is the longest, the midpoint one is the shortest. If the whole thing is 9, you have 6, and you have 3. So that's how it works. So that's what the problems are going to be like today. In the do section is just figuring out lengths of these segments. And this is what you need to know. So you can come back and refer to it if you get stuck on one of the do problems.